In this video, we're going to quickly cover an introduction to R and specifically working with data frames in R and data sets and looking at some of the things we can begin to do with data sets and looking at the basic syntaxes of the R language and some of the external packages you can use in conjunction with it. So to get started, you first want to install the base R package, and this will let you use Rstudio, which is the friendly interface. So to download the base R package, you want to go to their website, rproject.org, click on the CRAN mirrors list on the download header, and then find the mirror that's closest to you. And once you arrive at the closest mirror, you can download the relevant file for your operating system. So if you go on Mac, you can easily find the latest release, the latest package. And then if you have Windows, you can install R for the first time by clicking on their link there. Now, base R is the base language, and to use it, there is a friendly interface, Rstudio, which you can download at their website, rstudio.com. You go to Products, Rstudio, Rstudio Desktop, download, and then after clicking through multiple links, it should recognize your operating system and you can download the relevant file accordingly. So once base R downloads, you can install it, and then you can install Rstudio and open that up. So once you open up Rstudio, you'll be greeted with these three panels or windows. To open up a fourth window, you can click up here and it will bring out this window. And over the course of the video, we'll see the functionalities of each of these. But once you've opened up Rstudio, you probably want to get straight into working with a data set or a data frame. And on my desktop, I have a data set that I'd like to start working with. So there's a number of ways you can import a data set into Rstudio. The first one would be to come down here to the bottom right panel, and you can see that there's a whole bunch of files. So this lets you basically navigate your machine and look for whatever file it is that you want to load in. So since my file's on my desktop, I can click on air quality, I can import dataset and import, and Rstudio will import the dataset for me. And you can see a number of things have changed. In the top right panel, this is the environment section. There's a number of other ones, but for now, the environment one, you can see stores all your objects within R and its environment. So you can refer to air quality as an object or a data set or a data frame down here in the bottom left, which is the console. So here you can run whatever code you want to, and it will directly give you an output. In the top left panel, you can type code and you can run it by pressing Control or Command and then Enter. And it will run the code that you type in there, and the output will appear in the console. And you can save this file as an R file, and then you can access this code and edit it whenever you like. So this is like a document editor. Now, with this imported dataset now, there are a number of other ways you can also import it. One of them would be to use a read function. So you're reading in whatever file extension. Most Excel ones will work. They'll have an Excel or whichever extension, and then you can file.choose quotation marks, and this will bring up a directory or find a window where you can look for the file manually. So it's similar to the bottom right panel method. The final one, or another method, would be to use the working directory one. So the working directory is where R can directly access from the console. So if I look at my working directory right now, it's set to my home folder. I can set a working directory with setwd, and if I want the desktop as my working directory, I can copy paste that in and type desktop afterwards. So now my working directory is set to my desktop. So now, if I read in a CSV file, I don't need any of the other things. I can just directly use the name of my file. So that's airquality.csv, and I'll read it in. But as you can see, after I read the file in, it just appears here. Now, you can store an object or a data set into whatever name you like. So if I go my data, I can use a less than and then a dash or an arrow, and then I set that to be read.csv airquality.csv. So then if I press enter, it pops up in my environment, and now I can begin to use it or refer to it in the console or in my document editor up here. So now that we've imported in the dataset, there's a number of things you can begin to do with this dataset. So the first would be to go head. And that gives me the first few rows of my data frame. And in R, any function is a function, or it's a telltale sign if you see that it has a name and then the two brackets. And if you ever need help with a function, you can type a question mark in front of it, and that will load in the bottom right panel. So the bottom right panel has a lot of stuff, has the files, it also has plots, packages, and then the help. I'll get into those two later, but now you can see a lot of help in the documentation for this command or function. Another useful one would be names. And this gives an output of all the variable names of my dataset. Another one is dim. So this provides the dimensions. So data frames are similar to matrices in the sense that they have rows and columns, but each column can have varying types of data. So in this case, they all look pretty numerical, but sometimes you may have factors in here, categorical data, or characters and things like that. So data frames also have rows and columns. So here it's saying air quality has 153 rows and 7 columns. I can also find that information out with ncol, so the number of columns of air quality has 7, or I can use number of rows of air quality, and that tells me I have 153 rows. And if you're in the console and you ever want to use previous lines of code, you can press the up arrow key, and that lets you access all the things you've entered before, or you can come into history in the top right panel, and this has a history of all the lines of code that you've typed before. So now that we've had a brief sort of look at our data frames or data sets, we probably want to start doing maybe some more things with them. So one of the things that you can do with these data sets is start to index them. So to index a data frame, you can type its name and then 2 square brackets, and this will follow the format of rows and columns separated by a comma. So if you wanted to extract the first to the second row and the first to the second column of air quality, you can use this method with the square brackets, and that will basically index the data frame. If you wanted to access one variable, you can use a $sign. So air quality $sign, and it will provide a list of all the variables, and you can access that column alone, and it will list it out. And another thing you can do with this, similar to how you store an object, you can also set an object to something. So air quality, if I go head, just to show the first few rows, there's a variable x1 in here. Now x1 has no predictive signal. It's a unique identifier. So it's not going to be very useful, whether that's now or later, because R already provides an ID. So to get rid of a variable, you can set it to null. And now if you access the same thing, you can see that the variable x1 is now gone because we've nulled it or gotten rid of it. We can also logically index a data frame. So if you look at air quality, its head, the first few rows, maybe we want all the rows or observations that have an ozone value larger than 10. So to do that, we can go air quality again with the square brackets. And since it's rows in the first half and then columns in the second half of that comma, we can type our logical condition into the first one so we can extract all the rows that meet a certain requirement. So we want all of the rows with ozone from air quality larger than 10. As you can see, it'll print this version, this subset of our data frame. And if you want to save that, you can of course store it as an object, and then it'll come up here in the top right panel. So as you can see, the basic syntax already right now is quite logical and straightforward. If you wanted to find the number of rows that met this requirement, you can first go air quality, you can type in your condition here, and now it will return a whole bunch of binary outputs. So it's saying for the first observation, it's true, because our first observation, 41, is indeed larger than 10 in the ozone column. But it'd be false for some other observations, and for some, it'd be NA, because there are missing values in this dataset. If you want to find the total number of observations that meet your requirement, you can use the sum command or function. And you can find the sum of the air quality ozone being larger than 10. But since there are NAs, that's going to pop up as NA. But if you extend this and use col sums, so the sum of each column, and you get rid of this condition, you can find and extend your initial condition across the whole data frame and see how many columns, because we're adding up all of these binary outputs. So if you imagine we're testing air quality larger than 10. So in the wind column, it will test each of these observations, and this one would be false, false, and then true, and then it's going to do a whole column sum. And then all those ones and zeros add up, and it adds up to 72. For the ones with NA, it still has NA because these missing values have been added into the mix. And now that we're on NAs, another logical test you can do is air quality is.na. So is.na is another logical test, and it's basically asking, is it NA? So if we go air quality is.na, air quality ozone, this will return the subset of the dataset where ozone has an NA value. And by leaving the second half of the comma blank, we're keeping all the columns. So basically just going to file out rows 5, 9, and any other rows that have an ozone value of Na. And again, something useful of col sums is you can test the is.na condition across all the columns. And if you go to col sums is.na air quality, you'll find that it adds up all of the rows that test true for having an NA. And this way you can see the number of missing values in each column of your data frame. You can also use the which command to find out which exact rows meet your requirement. So here it tells me rows, all these rows, and this is the unique identifier on the side. But all of these rows have an ozone value that's larger than 10. You can also combine everything that we've covered so far, so all these logical conditions, and start to incorporate more conditions. So one of them is the exclamation mark, and that removes or excludes. So we can exclude all of the rows that have NAs in the ozone column. So saying air quality, and then we're going to index it, and we're removing the rows that test yes to the is.na test. We're going to exclude them with the exclamation mark, and by leaving the second comma half blank, we keep all the columns. And if you enter, it's going to print that. And then we can save that into an object, and it goes into the global environment. Now, you can also test multiple conditions and index that by using a $sign, an and sign. So perhaps we want the rows with an ozone value larger than 10, and we also want the ones where the temp is also larger than 10. By using that and, it tests both, and by keeping the second half blank, we're basically taking all of the columns. Something else that you might want to do is find the mean of a column. So R, originally being a statistical package, of course, has a lot of statistical functions in it. So you can easily find statistical summaries of columns. But because there are missing values, those are all added into the mix. So something you can do when calculating sums or summaries is to add an na.rm equals true. And this will remove all the NAs before you calculate the mean. As you can see, this will work and not show up with an NA. So base R and indexing data frames and just simple things like that follows quite a straightforward syntax. But there are also more powerful tools you can use to build upon the base R language, and these are packages. So here, R already has a whole bunch of built-in packages that come with it, that ship with it. And you can click tick on any of these to load them in. To install them, you can use either this install button up here, and then you can install packages, and you can separate multiple with spaces or commas. Or you can come down here into the console and use the install.packages function. And upon installing, it's going to install that, and then you access its family of functions by typing library dplyr, or whichever package you just installed. And that will load it and all its functions that come with it. So dplyr is a package that helps you really well with data manipulation. It has a lot of verbs or functions, commands that help you with manipulating your data. And that's specifically what we want to start doing with our data sets and data frames. So there are a number of verbs that will be useful in this package. The first two are select and filter. So select is for columns and filter is for rows. So say we want to select something from air quality. So we go select and then we give it the data. And again, if you don't know what it does, you can always use the question mark and go to the help section, and it will tell you how to use it and provide some basic examples. But we can go select, and then we're selecting from the data, and you can select a number of ways. You can go 1 to 3. That will select the first to the third column. You can also go by name, and that will just take out that column. And you can also do multiple, so you can add another one. And this will basically just extract those two columns. So similar to what we were doing before, but again, this is one of the simpler verbs. Filter acts upon rows. So filter, again, is like logical indexing. You can do logical indexing with filter. Again, we give it a data set or some sort of object to work with, and then we have to have some sort of condition. And upon entering that, it's going to print out and filter air quality based off ozone value being larger than 10. So again, similar to the square brackets, how we were using logical indexing, this can do it as well, but it can also do categorical indexing. So if we were to use a different data set, and you can do this. The thing with R is a lot of packages have built-in datasets that you can use freely, or data frames, I should say. So one of them is Iris. If we go head Iris, it's going to print out the first few rows. It's not in our global environment yet. If you do want it in, you can go data Iris. And it's going to load in Iris for you. So one of the things that filter is good for is providing a simpler syntax. So all of these verbs aim to provide you with an easier time. So filter Iris, and you can go species double equals is equals. So species is equivalent to setosa. And that's going to filter out all of the rows in Iris that match that condition. And again, you can use and for multiple conditions, or you can use the shift backslash, or like the stick, and you can use that as well. The third verb would be mutate. So mutate allows you to create new variables and preserve old ones, or keep the old ones. Basically, it lets you modify existing or old columns. So if we go mutate and we give Iris as our object now, we can set maybe a new variable called petal.square, and that would equal petal.length multiplied by petal.width. And it's going to print out that data set because we didn't save it as an object. But you can see a new variable that we defined that's based off some old ones. So now it shows the petal.square variable. Something that mutate also does is act dynamically, so you don't have to keep typing new lines every time you want a new variable. You can include it all in here, and you can also begin to immediately use the ones you just created. So if I wanted to go petal.new, and that would equal petal.square divided by 10. Then that creates a new variable in that line that's based off one that we just made. Another verb is arrange, and that just sorts the rows based off decreasing values or something like a similar condition. So if we go arrange Iris, we can sort it by petal.length. And by default, it will arrange it to be in ascending order. If you want it to be in the other direction, you can use a negative sign, or descending, so desk. And that will arrange it in descending order. Something that's useful with arrange is being able to arrange two variables. So we can arrange petal.length, and then from petal.length, we can arrange petal.width. And that's going to arrange petal.length in ascending, and then once it arranges that, then it will arrange petal.width in ascending as well. So you can see here it's 1.2, 1.2, 1.3, and then within the 1.3s, the petal.width is then increasing. So it does petal.length first and then petal.width. Something that is related to this is rename. So while we're still playing with all this, rename is also useful because it lets you rename, maybe you want to rename one of your columns. So I don't really like sepal.length, it's a bit too long, so I can type in a new name, maybe just sepal.l, and that would equal sepal.length. So the new variable equals this old one, and it will print out because I'm not saving this as an object. But if I wanted to save it, then that saves this data frame where I have a new variable name. Now, finally, we have the summarize function. So this will basically reduce your whole data frame into just a few columns based on what you summarize it by. So if we summarize median, if we give it the data first, the median is median petal.length. And that's going to summarize, it's going to collapse my whole data set and provide me with one value or one column which I defined. Now, so something that begins to help out a lot within typing cleaner code to start to manipulate this data is the pipe operator. So this pipe operator comes with dplyr, comes with a lot of packages, but since it comes with dplyr and we've already loaded that, we have it with us. So when we begin to find more complex functions, so maybe we want to filter out from iris the observations that have a petal.length is larger than 1.4 and the petal.width is larger than 0.2. We want to filter that out, but then we also want to select from that maybe just the species, and then we can count the species maybe. So if we enter that, there's quite a lot. And maybe you just want to count how many of these are maybe versicolor and compare that to how many are virginica. But once we begin to nest all of these things in here, it's just easier to use a pipe operator to break it up. So we start directly with our data set, and then we filter it. And instead of having, we don't need the data anymore because we've already started with it. And we can directly type our conditions. And then from there, we add another pipe operator, and this feeds into the next part. And then from there, we select the species, and it returns the exact same thing. So the pipe operator just really helps out with breaking up longer and more complex lines of code. What the pipe operator also is frequently used with in conjunction is the summarize and group by function. So if we wanted to summarize our data set, but we first wanted to group it by something, so to give us a bit more information than just one summary statistic, we could group it first, group by species, and then we could calculate a median using the summarize function. And this gives us a bit more information than just one summary value. And now this gives us 3 for each species in our dataset. Something that you might also want to do when starting with datasets is conditionally mutating. So if we go air quality, we might want to just get rid of the NAs in solar.r, the column solar.r. But we don't just want to remove those rows. If we wanted to do that, we could just go na.omit and then type in air quality and store that as a new object. But if you wanted to just populate all of these missing values in the solar.r column with a median of the rest of the values, for example, then you could begin to use an if-else test, for example. So of course you can get help, but basically an if-else function has a test, and then what happens to something if that test yields a yes or no. So if we had air quality wind, or since that doesn't have any missing values, air quality solar.r, and we're saying air quality solar.r is, and then we're going to use if else. So a test would be is.na solar.r. So the test is there a missing value in the solar.r column? So that's a test, and then a comma. And if yes, then we want the median of the rest of the column. And we use na.remove is true, because if we didn't put that, it just pop up with another na. So if the test is yes for is.na, then we're going to replace it with the median of the rest of the column. That's the yes condition. But if not, then we can just keep it. We don't need to change it. You can go air quality solar.r. So it's going to stay the same. And now if we go head air quality, rows 5 and 6 no longer have a missing value. Instead, it's been populated with the median. So if-else function is conditionally mutating parts of our data frame. Now, getting into the final things for an introduction into working with data frames is the apply group of functions and functions in general. So if we wanted to calculate the mean of all of the columns in our dataset, then we can use the apply family of functions. So if we go back to Iris, and we go pipe operator, and we're going to select 1 to 4. So we're bringing in everything now, all the dplyr verbs and everything and whatnot, and we're going to complete one final action. So Iris, and we're going to select rows 1 to 4, and then we're going to apply. So apply, we're going to give it an X or data, a margin, a function. So the data we've already supplied, it's out the front. Now we need a margin, and that basically tells you whether you want to apply something to the rows or columns. So we want to apply a function, in this case, mean. We want to find the average of each column. The margin will be 2. And our function is mean. So now we're going to apply a mean function to each column in the iris dataset for columns 1 to 4. And remember that we have to place an na.remove is true here, just in case there's missing values. I don't think there is, but this will basically find the averages or whatever function and apply it to each column. So this is better than maybe if you've done some programming before, it's better than opting for a loop because R isn't optimized for loops. And this way, instead, just quickly applies that function to each column. Along with apply, there's also sapply. So there's sapply and lapply. Sapply, not going into it too much, is a friendlier version of lapply. So it applies more broadly or friendlier. So instead of typing out all of this, you can use sapply as well and iris. And remember, we can subset or index the first to the fourth column. And by keeping the row section blank this time, we keep all the rows. So we're giving it some data, and then we're giving it a function. So sapply, we're going to apply it to the first to the fourth columns, and we're finding the mean of all of those columns. Sapply also works with any sort of test or function. So another function is class. So this helps you quickly identify what type of data it is that you're dealing with. So if we go class iris sepal.length, it's numeric. But if we were to change that and go to species, it would be a factor. And if you wanted to find the classes of all the columns, you can go sapply iris and then give it a function, and that function is class. So now we can find the class of each column of our data set, and that's sometimes very helpful. So we can also do that with air quality, and it will tell us that everything in air quality is numeric. Now that's sapply. There are also functions in R, and we'll see how functions tie in with all of this in dplyr later. But for a quick introduction of functions, you can save a function to use for later. So I'm setting a function to sum, and I'm going to set that as a function of x and y, and then in square brackets, I'm going to tell it what I want to do. So I'm going to add them up. So I'm setting a function of x and y to sum, and the function is x plus y. Now, if I apply that function to two numbers, x and y, it's going to add that up as defined by my function earlier. What you can start to do with something like this is define functions yourself and apply that to all the columns in a data set or data frame quickly and easily. So if I wanted to go head air quality, there's still some missing values in there. And maybe I don't know which columns has a missing value, but I just don't want to think about it. And I just want to apply and replace all missing values in whatever column with the median of that column. And I can define a function called median. It's a function of x. And then in my square brackets, I can go replace. And replace is another base R function. So now we're linking a lot of things together to accomplish our goal. And this is all pretty basic syntax, but we are linking everything together. So we're going to replace, and how replace works is you give it x, and then you give it some sort of list, and then some values. So if you search up replace, it's going to replace values. So we've made a function of x. We're going to replace the NAs with the median. And we're going to repeat that for each column by feeding our own custom function into sapply. So if we go air quality and 2 square brackets, and 2 square brackets basically maintain our data frame, and we go sapply, and we give it some data to work with, like before, and now we're using our function. So our own function is median. Now if we go head of air quality again, you'll see that the only value for NA that we did have in our visibility is now being replaced with the median of its column. And that would have repeated for all the columns because we're using sapply, and that will apply our custom defined function to the whole data frame. And something like that is usually pretty useful. Now, as an extension to this function, as the final extension, we can also define functions that let us find the top few values for each categorical level. So if we go back to iris and we go sapply iris class, we will see that species is a factor. And it has 3 levels: setosa, versicolor, and virginica. And suppose you wanted to find the top 3 petal dot lengths for each species. You could also do that with your own custom function. So if we define a function called top3, it's going to be a function of 2 things, x and a custom name. Now, we're going to start with x, and we're going to filter out each unique species by setting it as a function of x and name. We can start with something and filter out or repeat this function for each unique species by setting it to that name. And then from here, this is basically just starting with that data set, and we're going to select, say, setosa or versicolor, and then from here, we're going to then select petal.length and species. And then we're also going to arrange that by a negative petal.length. And then we're going to add a head. So the head function, as we have used many times, but now we're adding n is 3. So now we can take out the top 3 values for each unique level of species. And we can use lapply in this case because lapply is for lists and it's going to return a list. And that's what we want. Because if we actually go lapply and then we're going to go unique iris species, and this gives us the starting foundation to actually filter out all those unique levels of iris species. We're defining our function is top3, and we're giving it our total data set x is iris. So this is going to apply our function for each unique level of species, and we're going to use the function top3. And this will return the top 3 values for petal.length and for each species. So something like this, obviously this was for an extension on what we just covered. You can also do it with dplyr. And this is the thing with dplyr, is that it offers a lot of verbs that you can, search up on their documentation. And it gives you a lot of flexibility. So in this case now, we're going to go iris, and then we're going to pipe that in, and we're going to arrange it by descending. So we're descending petal.length. We're going to group by species. And then we're also going to slice. So these are all verbs and all little functions that you can use. So we're going to arrange it by descending petal length. And then we're going to group by species. And then we're going to take out the first to the third. And what this is going to do, if you can imagine each of these steps, is you're going to arrange it in a list in that certain descending order. And then we're going to group them. And then we're going to slice out the first to the third. And what this returns, unlike lapply, this method above, is you can actually save this. You can save this for later as an actual data frame if you wanted to. So the aim of this video was to just quickly provide some introductory syntax to working specifically with data frames in R, and getting started with importing them, installing R and whatnot, and just quickly getting in there